I'm going to go through my talk next. So I do apologise, we are running late. I'm going to talk about genetic preservation and cloning for breed sustainability and revival. So for that, I'm going to just introduce Gemini Genetics properly to you and tell you a bit about who we are and what we do, and then the ideas of genetic preservation and cloning, the applications of that for conservation, and then I'm going to finish on the charity that I've mentioned this morning already, Nature's Safe. So Gemini Genetics, we are a genetic preservation company. We are preserving DNA for future use. And we work with skin samples. So rather than a Lincoln facility that work with semen, we work with skin. And we work with skin because that enables us to capture the whole genetic profile of that individual. And we can capture that whether it be a male or a female, whether it be neutered, castrated, whether it be a young animal or an old animal. We are associated with Biogen Pets and Equine. So in terms of a commercial output, we are associated with cloning. But we do a lot of work with rare breeds, and as I've said already, I also work with the charity Nature's Safe, so that's how we fit into the conservation sphere of things. So where did we come from? Our founding was really with, so I also belong to the Stallion Company here, and as part of that Stallion Company, we do a lot of work with rare breed horses, and our founding was really from our work with rare breed equines. We've been banking semen for rare breeds, but we really wanted another way of effectively banking those populations for future, because semen is only for the males. We're only getting half the genetics because it's gamete. So we really wanted a way of how can we preserve the females in particular. So this is really where we came from, and then we began to offer for domestic animals, so cats, dogs, and horses for cloning. But it was really for the plight of rare breeds that we started the company. So we are partnered with Biogen Pets and Equine, and my student Eloise is going to do a talk for us this afternoon. We've got a recording from their Chief Scientific Officer for this presentation, so you'll get to hear him and what he's got to say after mine. They're world leading in their sphere. They've been going for over 20 years, cloning cats, dogs and horses, and they also have a second company that works within the livestock sector. They work with domestic animals, but also you're going to see that they also apply their techniques to conservation. And this is kind of what we're kind of emulating here with Gemini in the UK. So genetic preservation, it's indefinite preservation of DNA. It can be for immediate use, or it can be frozen for future use. And it's really the banking of genetics for future use that's the key message that I want to sell today. We work with skin, as I said, and it's a similar concept to semen freezing. We're banking the skin down to -196 degrees. In liquid nitrogen. At that point, the skin stops any deterioration of it, and because we've got special medias that we can use, we can then thaw them out and be able to use that those genetics in the future. The skin samples can be submitted to us before or after death, depending on country location and vet discretion. Most of our samples at the moment, though, do come in after an animal's passed away. We do have a number of privileges working with skin, so if anybody knows about whenever you're working with semen, when we're doing a post-castration epididymal semen extractions, the semen out the testes after they've been removed, you have to get those testes to us really quickly on a same-day basis. With skin samples, you've actually got up to 5 days after an animal's passed away, or 5 days after the skin's been taken to get it to us here on the centre. So that removes that big time pressure. An important note, you have to keep the skin chilled, never frozen. If you just put a skin sample straight in the freezer, it will snap the DNA, the base pairs between the DNA helix. So that's a really important note, and I've got a closing slide which gives you 3 take-home messages, because there's nothing more disheartening for me than I get a phone call from somebody wanting to preserve their animal's genetics, and I ask where the body's been stored, and they say in the freezer, because my answer to them then is this is not likely to work. Your chances of viable recovery is going to be dramatically reduced. So keeping it chilled is really important. We are just using the upper skin layer. So Dave said that it's minimally invasive. We are just wanting skin. It's either taken as a biopsy punch, or in a post-mortem sample, we have a snip off the ear. We use skin because skin really likes to regenerate. If you cut yourself, your skin will naturally start to heal, sometimes on the same day, but it will regenerate really quickly to heal that cut. But if we think about muscle tissue, you could pull a muscle, damage a muscle, and be out of action for months. So that's not as regenerative. And fat is a different tissue type. So it is just the upper skin layer that we want. Anything deeper will just get trimmed away. So we just ask for that skin. And it's the whole genetic profile that we're getting of that individual. So it's that whole unique DNA profile of that animal. So again, different to semen where you're only getting half and you're not quite sure what mix you got in that semen of that animal. Taking a skin sample, it's that whole profile. We then move on to cloning. So the other word for cloning is somatic cell nuclear transfer. So it's basically producing a genetic twin to the original animal. So we start with the original, we take a skin sample, and then I'm going to show you a diagram in a minute that explains the cloning in more detail. There's 3 applications to this really. There's people wanting to clone their pets really for the love of that pet, and I'll expand on that in a minute. There's the performance side of things, so that's more related to the equine side. So if there's a really good mare, stallion or gelding that they want to clone and bring back, and I've got some examples of that. And then there's the conservation side of things too. So these are just a selection of some of the cats, dogs and horses. There's lots of them that have obviously been cloned, so not indefinite, but these are just a few of them. So how do we clone an animal? So we start off by taking the DNA from the from the animal we want to clone. I do hope I've not got that. And so we take the skin sample, we preserve that and we culture that up in the lab, and I can show you downstairs. I've actually got a dog sample and culture downstairs that I can show you when we break you up into smaller groups. We then take an egg cell from a donor. We take out the DNA within that egg cell and we implant the DNA that we've multiplied up in the lab. We then stimulate that egg with an impulse, and that will mimic what happens when a sperm and egg fuse together. So that egg will then think it's been fertilised. That will then go into carrier mum, who will then carry the package home. And this is a video. So taking out the DNA of the donor egg, called egg enucleation to start off with. So that is that little bubble coming up just now. I'm just going to repeat that so long. And then the next process is reconstructing that egg. So this is the DNA of the animal that we want to clone. So they are collecting it up there. And we've got some more videos later on from Biogen, which we can elaborate a bit more on this process. And then these are the eggs that are going to hold the DNA. They're then going to inject in. And the DNA sits, and after that the impulse will be applied, and then that will begin to mature. You just do the same again. I'll let you watch one more and then we'll tell you another. That's really unique footage that I got from Biogen. So that's I always those videos were a lot longer. We've trimmed them down, but yeah, we're going to see them more later on. So Tillis mentioned her before. She hasn't actually made an appearance yet. I'll have to go and remind Tillis that he needs to bring her up. So we do have a cloned dog on centre with us, and she's really special. So the cloned horse outside isn't a horse that started with us. Biogen Pets and Equine cloned the horse, but the skin sample didn't start with us. It was before we started the company. But Jen, she very much began down in my lab downstairs. So she's really special because I kind of feel like a weird surrogate mother to her, because she started off in my lab and then come full circle back to us. She's a lovely girl, and it'll be lovely when she comes up later on. So an intermediate stage, so we start off by preserving the DNA so that it's not going to degrade, and then we need to multiply up that DNA. So we want to only take a small skin sample from an animal. So by multiplying it up, it means we don't need to take a vast skin sample, but also to be able to create new life from a skin sample, we need that DNA to be capable of regenerating. It's got to be able to replicate and so on. So we do that via the cell culture. And I can show you the CO2 incubators and show you a live cell culture that we've got going at the moment. So why do people clone their pets? I feel there is an element of a misconception that is perhaps the wealthy people wanting to clone handbag dogs, and there's perhaps not really much emotion in there. There actually is an awful lot of emotion involved with this process. Owners come to me when their animals have passed away, and Some people will have different relations to their pets. Some people will view their pet as it is just a pet, and they can accept when they pass away, they can accept that loss and move on. But others, their animals become integral parts of their family, and the loss of that pet is something hugely significant. So for the vast majority of my clients, yes, there are a few that are very wealthy and they probably have got sufficient family that they can own a pet. The vast majority, though, 80%, if not more, are doing it purely for their love of their original animal. Lots of our cats and dogs will be neutered when we're talking about the general pet industry. So they won't have the option of having a sister, a daughter or a son from their original animal. So it's really important that they can clone and have an everlasting bond with their original pet, continue their pet's legacy. And really what they're looking for is to be able to bring back the little memories and the little things that were unique to that animal, and they mean an awful lot to them. I do have a lot of people, though, that will just get a lot of comfort just from preserving their pet's genetics. I very much don't push them into cloning. You can preserve your genetics and think about what you want to do. And for a lot of people, just preserving those genetics in a way that you could potentially clone in the future, it means when you lose that animal, the door isn't completely closed to them. I think grief's always a very sudden thing, even if you know that pet's poorly. But by preserving the genetics, you haven't completely closed the door to that animal, and that can give people an awful lot of comfort. Other reasons why they might want to clone are for working dogs. And Biogen Pets and Equine do a lot of working dogs, especially security dogs. Also females, so we can't preserve eggs too well at the moment. So if you're wanting to preserve your full female line, the only real way of doing that at the minute is with cloning them. We can do embryo freezing and so on, but that will be diluted by a male. So your pure female lines, cloning that's where genetic preservation and cloning comes into. There is potentially increased predictability of the offspring. If you've got the original and you know its performance, you're potentially going to have less variability in the clone because they're going to have exactly the same genetics as the original. So you have the same genetic potential to go and achieve the same as the original. And so therefore potentially reduce failure rates, as they so term it, in the working side of things. And that's why Biogen do work a lot with the security dogs in particular in the States. I introduced this before. We have a really good record. I think it was Tullis actually talking about our record keeping. So it's really important we know all the samples. Skin looks fairly generic across everybody. So we have a really first rate. It's a human IVF adapted system, Matcha Technologies, that we use for labelling all our chirovials. And moving forward, everything that we do in the lab will be barcoded uniquely to that animal. So we'll have a little robot that when we bring a bile out of storage, the robot will scan the barcode and therefore independently verify we've brought the right animal out of storage and so on. Our storage is really important as well. These samples mean an awful lot to clients, whether that be because it's a much valued pet, or it's a much valued performance horse, or it's an integral rare breed animal. So we have the fully alarmed, fireproof rooms, CCTV monitoring. The alarms on the tanks are connected to our phones. So if there's any issue with the tanks, there's numerous people that are called to say there's a problem, so we can go back and see what's happening. So to give you some costs, so to preserve the pet's genetics, it's £500 plus that. To then multiply up, so cell culture, that's £1,400. We have £12 for another storage for the samples. And to export to Biogen, where we currently do the cloning, is about £800. Obviously, the big money figure on there at the minute is for cloning, so $50,000 US. I appreciate a lot of you will look at that and find that an eye-watering price. I can't afford that myself, most definitely. But what I'm here to say, though, is that it all depends on, one, that price very much depends on the animal that you're cloning. But even if you're not ready to clone, the initial preserving is only £500 plus that. So that is the real key thing, that we have a low-cost way of preserving genetics for the future that we can then bank and pick what we decide to use in the future, should we decide to do so. So although there is no, once the samples are preserved, they are preserved indefinitely, so there is no pressure to be having to worry about paying $50,000 in the future. I have talked to a number of people during break, though. One of our targets with the company would one day be able to bring cloning over here, which would reduce the cost and hopefully increase accessibility for people. The other use, though, of the skin samples that we're preserving and the one that we're looking at for the charity Nature's Safe is to be able to turn those skin cells into pluripotent stem cells. So turn them potentially into sperm or egg cells. Then we can create fresh individuals, new individuals from a skin sample. So that is one of our long-term goals as well. But again, you need to have skin banked in the first place in order to be able to work on this in the future. So in terms of the principle of genetic preservation for rare breed survival and sustainability, we want to preserve individuals genetically representative of the breeds and species. That's the ideal thing, that we'd like to bank down a number of individuals who are key players in the breed sustainability and diversity. Then if we come to a place of having a breed or species related challenge, or we find we're going down that route of the small population verging on the vortex, we could then look at recalling somebody that was in existence maybe 30 or 40 years ago to bring back genetic diversity in that population without your outbreeding or crossbreeding. Because after that 30 or 40 years of breeding, since they've been banked, the current population might actually be quite genetically dissimilar to that sample that you banked 30 or 40 years ago. And this is basically the principle that was done. So Biogen, Pets and Equine, they're now more on a regular basis working with San Diego Zoo and Revive and Restore. And they were responsible for cloning first the seahorse. So his surrogate mum was an equine. And he was produced from a skin sample that was preserved 40 years ago. So San Diego Zoo had the premonition of banking samples in this way. They didn't know what they were going to be used for, but they just started to bank samples for future use. And it was only 40 years on that we've then got a technology that's been able to utilise that. They identified this sample to come back because that sample is genetically dissimilar, the most genetically dissimilar out of all the ones they banked to the current population. So that Royal Ski Horse is now in the breeding population and has introduced genetic diversity without crossbreeding. Another example is the black-footed ferret. So it's the same concept. This one was a skin sample that was preserved 30 years ago. This breed, the black-footed ferret, they've got a very small number of founder animals in their population, and they're also challenged by they're really susceptible to certain type of plague. So they've got a number of challenges, and again, they went back to the bank of samples that San Diego Zoo had the premonition to bank away. They identified the one that was least related to the current population, and they cloned her, and she's called Elizabeth Ann. I believe Eloise might have some videos of her a bit later on. She's a nice little ferret, quite that ferret. But I do know that also Biogen, Pets and Equine, this is a story they're continuing. They have got other projects I can't reveal them, but basically keep an eye on it because this is the technology that in the States for zoo animal conservation they are increasingly looking at. The other thing is that we are working with a number, this is not necessarily the rare breeds that we're working with. I can't disclose the ones that we're working with, but we are working with a certain number of horse rare breed societies to bank down skin samples. So they are already thinking about banking in this way, not because they can afford to clone all their animals, but just that they are banking for the future so that they have it there to come back to if they need to. We've mentioned Murkish Gem a couple of times, so that one is Murkish Gem. So here is his original number one, who was a gelding, Gem Twist, who was a US show jumper. They gelded that horse, so they took off his testicles when he was quite a young age, and then he went on to be a really good show jumping horse. And obviously, having removed that reproductive organ, they couldn't breed from him. So the only way that they could, when he passed away, that whole unique genetic set that they knew worked really well, and you've got really good competition genetics, that was otherwise going to disappear completely. So they took 2 skin samples and they cloned one horse, which is Murkish Gem, and there's another one called Gemini, which stands in France. And Murkish Gem is now at a really exciting point in his career where we've got his progeny out in the competition circuit as well. So with horses, it takes at least 3 to 4 years. It's longer still. before you're actually able to get them out and competing and see the results. But these progeny are showing the transfer of genetics. They are out there. Dave mentioned before the number of health papers he finds for this horse's semen to be exported and sent around. So people are breeding from him, they're getting the competition results they want. And it's quite an exciting story because we can get to watch his story go on basically as these animals more and more go out in the competition circuit. Other examples for you, I don't know how horsey you all are, but there's William Foxpitt, very good horse, sadly, eventing horse, sadly died. Chilly Morning, they now have at least 3 clones of him, and 2 of them are out competing. One they're just using for breeding at the moment. But again, they're showing the transfer of those competition genetics, the traits that they're wanting to the offspring. Another one is this horse here that stands in Ireland, cruising. He passed away. They made 2 clones from him, Encore and Irish. And again, they are showing very good competition results, so the transfer of those genetics. We've recently had another announcement of, also from Ireland, the cloning of a Shodan Stallion Puccino. So this, basically with this horse, they didn't bank semen from him. They didn't realise his worth until later on in life when it was too late to bank the semen from him. So they took a skin sample just before, in advance of him passing away. This horse is now a 3-year-old, so they did decide to wait until the horse was 3 before announcing it. But as you can see here, it's saying it's a carbon copy of the original. We don't, whenever I'm talking to people about cloning, I don't say the word carbon copy because we are never going to get an exact copy of that original animal. That was an original animal in its own right. But what we are seeing as more cloned horses and other animals come through is we're getting to hear from the owners themselves of the many similarities that they are seeing in the original. So that's another exciting one for us to watch as he now goes into his breeding career. So I touched on this before, that we are doing work within rare breed horses. We need to do more work. We are doing work within wild and endangered animals, but we don't yet have a biobank for farming and livestock, and we really need that for our breed and future security. And I touched on those conditions such as the avian influenza in a minute to show that. So cloning and the original, how similar will they be? The clone and the original are genetic twins, so they will have exactly the same genetics as one another. They're essentially identical twins, but born at different times. So the clone will have the building blocks to become the same as the original, and it will be the closest living replica to the original animal. And we've got some more pictures there of clones, perhaps seeing the similarity between them. However, we do need to remember the influence of the environment. So although they will have the same genetics to start off with, that is your building blocks upon which your environment feeds. So one thing you can't do is clone your animal and then kind of put your feet up and expect it to become the same as the original. You've got to put the same environment in there. And where we might start seeing more variability in an animal is if it's one that we've maybe had a rescue dog and we've not owned it until it was maybe 10 years of age, and there's a lot of environment going on before then that we don't know. I've kind of touched on it a bit today to people that have asked. The technology we'd really like to develop alongside Gemini is genomics, which is the technology where we can start to understand the genetics behind the traits that we're looking for, and that could actually enable us to start putting a percentage on what percentage of this animal is due to genetics and what percentage is due to environment. Other applications of cloning, so I've already touched on preservation of female lines. So this is a campaign that we're running this year in particular for horses, really reaching out to the mare sector because there are a number of really important female lines that we need to preserve down, and that will be comparable for your dog breeds as well. And once those female lines go, we can't get them back. So we can't freeze their eggs, and as I say, frozen embryos are great, but they are diluted by the male line. So taking a skin sample is really important for females. Now we have left the EU, there is potential room for cloning to return to the UK, and this would allow for further development of the technology and exploration of it. We are a bit blinded at the moment by we can't have it here in the UK, so we can't investigate and potentially move its potential on a bit more. and hopefully possibly lower the cost as well, which would make it more accessible. So that's something that we're working on as a long-term goal for the company. As I said though, I'm also scientific advisor for Nature Safe, and it's really working with the domestic animals and doing the genetic preservation there that's enabled us to transfer it to rare breeds and in turn to saving rare species. So I'm going to give you an overview of Nature Safe. Although it's about wild and endangered animals, hopefully one will find it really interesting. You might also find some of the figures a bit startling and a bit doom and gloom. How on earth do we do all the work that we need to do? But also it is relatable to your saving of rare breed dogs, because we're working with small populations and we're needing to work against a really rapid decline in diversity to save animals. So Nature Safe, it stands for Saving Animals from Extinction, and we do tissue banking, so we preserve skin samples from wild and endangered species alongside assisted reproduction technologies. So going back to my diagram at the beginning where I said we can't just rely on one technology. We don't just want to bank skin samples, we don't just want to bank semen, we want to be banking a variety of things, so we've got a number of strands to work from in the future. So the mission is to save animals from extinction by collecting, indefinitely storing and regenerating reproductive cells and cells from endangered animal species. The regenerating bit is the key part. So you may see other biobanks out there, and if you're thinking about going into the biobanking sphere, it's really important now that we have the regenerating part. So we can put DNA in a freezer and you can bring it out and have a look at its structure, but we now need, because we've got such a rate of species loss or breed decline, whichever angle you want to put it on, you need to have those samples to be capable of regeneration so that you can actually bring back a living organism potentially from them in the future. We've published a paper and we've got a few more in the pipeline because what we're doing is actually quite unique. This new way of biobanking in a regenerative way is a relatively new concept. So especially for the UK here, so resurrecting biodiversity, and you can still find that that's open access, but that gives an overview of all that I'm going to talk about in the presentation. So in addition to Nature Safe, there are several other biobanks that exist. And as I said, there is some difference between them. Some of them are just banking it in a way that they can just look at the DNA, whereas others are banking in a way that we can bring them back. The rate of species loss, though, and some of you during break time were talking about what's the point in kind of banking your dog samples down if the kennel club won't register them at the moment. Well, if you're losing animals at the minute, you need to bank them down so that you've got them there for the future for if the situation changes in the future. Once an animal's gone, we can't go back to them. So this is the real key thing about banking samples now, when we know there's a problem or the start of a problem, so that we've got it there for the future. So yeah, just making the difference here in that we are all about retaining the living format. So whether that be semen, freezing that, we are essentially freezing it down, but it's able to wake back up and become alive again. And that is really important because there are other options of just freezing down at -80, for example, but that will kill the cell. You can still wake it up and look at it, but you're not going to be able to get a living animal from that. So that's really important that we've got the -196 storage and of course our extenders that we're freezing in. So we saw this graph before about the rates of extinction, and 1/3 of all species face extinction by 2050. So that is less than 30 years' time. So that is an astronomical loss of species, and that's going to have humongous consequences on us. And we saw this one before, that we're in the 6th mass extinction. That is official now. We are in that mass extinction. And there's a number of species being challenged, amphibians in particular, and they're actually quite difficult for us to work with at the moment in preserving their skin samples. The other thing that we're working against, though, the charity with global biodiversity loss is obviously the other pressures such as climate change. That's going to make the environment more challenging for species that are already being pushed to the limit. And very, very much saying that our future is now. So again, this is talking in terms of wild and endangered animals, but if you've got a really small population of dogs, you can't wait until 5 years down the line or 10 years down the line. You need to be doing something about that now while you've got the individuals that you've got available to you, predicting that you're going to potentially have less available in the future. So this is the slide that I showed you before, where at Nature Safe we're banking down a variety of different sample types so that we're not reliant on just one individual. So there's an example, and we aim to provide the Millennium Seed Bank equivalents for our animal kingdom. Revive and Restore are the group that are behind the horse spawning and the black-footed ferrets, and are continuing to work with Biogen Pets and Equine on the conservation side of things. So you can see here that they're very much saying about banking what you've got available, increasing time, you're banking for an unknown future, and really of further applications for those materials that you've banked to help recover species that you've lost. So the samples we work with at Nature Safe, we work with post-castration epididymal semen. So we don't routinely, there are the occasional animals that we can do live semen collections from, but most of them we're receiving testicles. We preserve the semen, but we also preserve the testicular tissue. The ovarian tissue, we can only preserve the ovarian tissue at the minute. Again, we can't freeze eggs, so we are just relying on that for the ovaries. And then we've got the skin samples. So the post-castration epididymal semen extraction, so semen is produced in the body of the testes, and then it drains into the epididymis, which sits alongside it. And we can basically hone in on that, remove the epididymis, and take out any available semen. It works with variable success. A lot of the testes that we receive for Nature Safe, the animals are maybe have been quite poorly prior to them passing away, or they're quite old, or they're quite young. So we don't, it's a trickier one. Some of them are not very viable that we get in just because of the animal related factors. But we have successfully preserved from a number of species, and these are just a few of them. And oh, here you go, that's a video of some cheetah semen. It's actually reasonably okay quality in terms of cheetah, so cheetah don't have that brilliant semen. This cheetah was an old one as well, and he's got arthritis and a number of other background issues going on, so we were quite happy with him. We had some Komodo dragon testicles coming the other day, and some semen from him as well. So yeah, we do get to see a lot of variability of samples, and it's quite exciting when you get an unknown species that you've not worked on before. See that. And so as well, we do try and carry out live semen extractions where possible. Obviously, for the majority, the animals are sedated. It's not a live collection. You regularly do it with your dog or your horse. And Tunis has gone out to South Africa, freezing off elephants and rhinos. Then we also, so once we've got the testes, we don't just discard them. We dissect them into little strips that produce the semen, and we preserve them down with view of being able to wake those back up and produce fresh sperm in the future. And it's the same with ovarian tissue. So we have our chief scientific advisor, Susanna Williams there. She's part of the Rhino Fertility Project, and she's basically brought this technology to us of how we can preserve ovarian tissue with view of waking it back up in the future. So these are some pictures of little strips of ovarian tissue. There's the remains of the ovary there, and we're going to preserve them down. We preserve at least 10 vials per animal when we're banking for Nature Safe, because for a lot of these species we might not have a protocol that we know definitely works for reviving their skin sample or their reproductive organs, so we have to have samples banked for developing protocols too. So these are some of the species that we've already worked with, preserving their ovarian tissue, and there's been lots more since. I had a leopard ovary in the other day, and that was the best ovary to look at. It was like perfectly formed, and yeah, it's quite special to be working on that one. And then we've got the preservation via skin. So we do bank down skin samples for all the samples submitted to Nature Safe. And again, relating to that, to you as rare breed dog owners, Nature Safe are not banking those skin samples just to clone all those animals. Yes, they might decide in the future they might pick out a few. They may, or they may not, they may avoid that technology altogether. But they're banking it for future uses, whether that be turning into a sperm or an egg cell or another use that we don't yet know of. So they are banked down in equal proportion to the reproductive samples. And we are constantly testing, we choose animals that we're going to test the South Ultra on to make sure the samples are bank viable. So this is a cheetah. We've done African wild dog, jaguar, onager, a few others. And so far all results they've cultured within the targets that we need them to. So that means we're banking down the samples in a way that we can revive them in the future when they need them. So their potential more application is for turning those skin into sperm and egg for new individuals. So to give you an idea, Nature Safe started officially, I think about 2 years ago, or it may have gone on a third year, time goes rapidly by. But we've already banked 389 samples from 233 animals and 144 species. This slide is possibly a little bit outdated, so it will likely be more than this now. But what we're basically looking at is we have the pre-setting to the prior day where we had biodiversity and bioabundance. We're going through the present day challenges where we're losing a lot of species and so on. If we can bank as many species as possible, potentially with future technologies, we can reintroduce that genetic diversity and go back to a planet that we once knew. We very much, whenever we're talking about Nature Safe, it's very much a collaborative effort. It's about everybody working together. And we very much reiterate that the future is very much now and it's in our hands. So again, relating to you guys with Rare Breed Dogs, we need to all talk together, be freely working with each other to produce maximum effect in terms of saving these breeds. And the future is very much now. It's too late to wait in 5 years' time where your numbers will decline further. So we need to be banking now for this. So if anyone would like further information on Nature Safe, Tullis is the go-to contact that I've put down. Tullis is the founder and chair of Nature Safe, and there are the details. You can go and visit the website and learn more about them. If you want to learn more about us, you've all got a goodie bag with the information in there that you can reach us and go to our website and so on. My key points thing is that if you are thinking about preserving your pet's genetics, we need a skin sample only. It needs to be within 5 days of your pet's passing, and your sample needs to be kept chilled and not frozen. So if you are thinking about doing this, please talk to your vets and make sure if you do find yourself in a predicament of your pet's passed away, potentially on plans, they need to be chilled storage and not frozen. That's a really important point. So I want to be able to help you when you call me up. And just to say thank you very much for listening.